Hello friends, welcome to our YouTube channel Anand Academy of Education. From now we're going to start this new chapter, atomic structure. Atomic structure. This is a very basic and very fundamental chapter in order to understand the concepts of chemistry. The reason why we need to study this chapter is because this is the fundamental chapter in chemistry. Usually in chemistry we deal with a lot of chemicals, lot of molecules, compounds, and etc. etc. And as we know, everything in this universe is made up of atoms. So it is better for us to understand the concepts of atoms to understand the concepts of chemistry in a very easy way. So we need to study this chapter thoroughly to understand the concepts of chemistry easily. And I will teach you this chapter in a way that you can crack any exam. You can crack in your intermediate exams or Eamcet, Neet or JEE, mains or advanced, or any other state engineering entrance exam. Alright, so let's start. So the concept of atoms. So when was this concept of atoms proposed? So when do you think people have thought of these atoms? Yes, people thought of this concept of atoms around 400 BC. So this concept of atoms is not a recent study. So this concept of atoms has been in existence since 400 BC, since the time of early Indian and Greek philosophers. Alright? So this concept of atoms has been in existence from early Indian and Greek philosophers. And what did they think of these atoms? So they thought that atoms are the smallest particles in this universe. I will give you an example. For example, let's take wood. Okay? So this is a wooden object. So after taking this wood, we try to cut this wood into tiny pieces. Alright, we cut this wood into tiny pieces. Let's say this tiny piece is A. Alright, and again we cut this tiny piece A into much more smaller pieces B, and again we cut this smaller piece B into much smaller piece C, and again we cut this smaller piece C into much smaller piece D. And if we go on cutting these smaller pieces into much smaller and smaller pieces, what we will get at the end is atoms. So in wood there are wooden atoms. Likewise in glass there are glass atoms. There are atoms that are associated with glass. Alright. So glass is made up of glass atoms. Likewise carbon is made up of carbon atoms. Oxygen is made up of oxygen atoms. Likewise, everything in this universe is made up of atoms. And that's the reason why we need to study this chapter. We need to study this concept of atoms to understand our universe. For example, oxygen has some chemical properties. Carbon has some chemical properties. Nitrogen has some chemical properties. So why are these chemical properties different? Why are the chemical properties that oxygen has are different from the properties that carbon has? Why do they differ? So in order to answer such questions, we need to study this concept of atoms, because atoms are the fundamental building blocks of matter. So everything in this universe is made up of atoms, and that's the reason why we need to study this chapter atoms thoroughly. To understand the concepts of chemistry in particular, we need to understand these concepts of atoms. We need to study the concept of atoms, and we need to understand how atoms behave in each element. Alright, and the word atom is derived from the Greek word atomio, meaning uncuttable, So this word atom is derived from this word atomio, which means uncuttable. So atoms cannot be divided. Atoms cannot be divided further. So that is how this word atom is derived, which means uncuttable or non-divisible. So atom is the smallest particle in this universe. If there is any such particle in this universe which is very, very small, then that is atom. Okay. But as we know, there are other subatomic particles. We know that there are subatomic particles like electrons, protons, neutrons. But during the age of Indian and Greek philosophers, what they thought is that atoms are the smallest particles in this universe. They did not know about electrons, protons, or neutrons. What they knew at the time was only atoms. Alright? So to sum up these 3 points, so the concept of atoms has been in existence since Indian and Greek philosophers, that is 400 BC. And atoms are the fundamental building blocks of matter. So, and let me also tell you this meaning of matter. So what is matter? Matter is anything that has mass. Matter is anything that has mass and occupies some space. Matter is anything that has mass and occupies some space. So if we take wood, it has some mass. Here we took the example of wood. So wood has some mass and it occupies some space. So it is matter. Likewise glass is matter. Likewise oxygen has some mass and it occupies some space. So it is matter. So everything in this universe, everything in this universe is made up of atoms. Just like how cement, soil, etc. build houses, the atoms together build this matter. Atoms together build objects. Atoms together build gases. Alright. So let's move on to the next slide. First theory on atoms. Though we have this concept of atoms since Greek or Indian philosophers, we have this concept of atoms since Greek and Indian philosophers. But the first scientific theory on atoms was proposed by John Dalton. The first scientific theory was proposed by John Dalton in the year 1808. Greek and Indian philosophers thought of atoms, but they did not have any scientific proof to prove that atoms are the smallest particles in this universe. Or otherwise, every object is made up of atoms. So the idea of atoms during the times of Greek and Indian philosophers was just a mere speculation, was just their thought, was just their idea, but they did not have any evidence to prove that everything in this universe is made up of atoms. So they just thought that there is something like atoms which builds everything in this world, in which every object is made up of those atoms. So the concept of atoms during Indian philosophers was just an idea, was just a thought, but they did not have any evidence to prove that everything in this universe is made up of atoms. But it was John Dalton who in 1808 did a scientific study and came to a conclusion that matter is made up of atoms. So he, with some proof, concluded that matter is made up of atoms, and he said that atoms are undivisible. And he said that atoms are undivisible. If undivisible, they cannot be divisible. For example, if it just like how we took the example of wood, so if we can cut this wood into tiny pieces, we can cut this wood into tiny pieces, but we cannot cut these atoms into much more tiny pieces, and that's what John Dalton said. So what John Dalton said is that atoms are undivisible. So these are the smallest particles in the universe. These are the smallest particles in the universe. And all atoms of a given element are identical in mass and properties. For example, if we take carbon element, then all the atoms of, for example, if we take two carbon elements, so the carbon elements here in this first element and the carbon atoms here in the second element are same. They have same mass and they have same properties. And compounds are combinations of two or more different types of atoms. And compounds, for example, NaCl, this is a compound. So it is a combination of sodium atoms and chlorine atoms. So this is a combination of sodium atoms and chlorine atoms. And also he said that a chemical reaction is rearrangement of atoms. For example, if carbon combines with two oxygen atoms, what we will get at the end is CO2. So according to John Dalton, this chemical reaction is just rearrangement of atoms. So one carbon atom and two oxygen atoms just rearranged themselves to form CO2. So these are the points that John Dalton made after his scientific study on atoms. And this is the scientific study on atoms. We had the concept of atoms since 400 BC during the time of Greek and Indian philosophers, but there was no evidence for them to prove that everything in this world is made up of atoms. But it was John Dalton who in 1808 made a scientific study and concluded that matter is made up of atoms. Drawbacks of Dalton's model. What are the drawbacks of Dalton's model? So John Dalton made a theory on atoms in 1808. So he said that atoms are undivisible. But this is wrong. But this statement was wrong. In the 19th century, in the 19th and 20th century, scientists made several scientific studies and studied the properties of atoms and studied the structure of atoms. And when they studied the structure of atom, what they found is that atom can further be divided into electrons, protons, and neutrons. And so the statement that atoms are undivisible is very wrong, because atoms can further be divided into electrons, protons, and neutrons. So atom is not the smallest particle in this universe. And John Dalton was not able to explain this property. For example, when a glass rod, let's take a rod. When a glass rod is rubbed with silk, this is a glass rod This is a glass rod, and when this glass rod is rubbed with silk, when this glass rod is rubbed with silk, the glass rod gets positively charged. This gets positively charged and silk gets negatively charged. Why? John Dalton could not explain this. John Dalton could not explain this. Why does this glass rod gets positively charged? Why does this glass rod get positively charged? Why? This is because there is flow of electrons from this glass rod to silk. When silk is rubbed with glass rod, when silk is rubbed with glass rod, the electrons in the glass rod started moving from this glass rod to silk, and that's the reason why the number of electrons in silk got increased, and that is why this has become negatively charged and this has become positively charged. There is losses of electrons in this glass rod, losses of electrons, and that's the reason why this is positively charged and this is negatively charged. But John Dalton could not explain this phenomena. So this is one of the major drawbacks of Dalton's model. So the first drawback is, he said atoms are undivisible, but atoms can be divisible. There are much more smaller particles than atoms. There are electrons, protons, and neutrons. And also he failed to explain this phenomena, how glass rod gets positively charged when it is rubbed with silk or something like fur. Alright. So discovery of electron. So in the last slide, we studied that atoms are divisible and atoms can be divided into electrons, protons, and neutrons. An atom can further be divided to electrons, protons, and neutrons. So atom is not the smallest particle. There are much smaller particles than atom, which are electrons, neutrons, and protons. And how was this electron discovered? So let's study how electron was discovered. So firstly, who discovered electron? So it is J.J. Thomson. It is J.J. Thomson who discovered the electron. So how did he discover electron? By using cathode ray discharge tube experiment. Okay. So what is cathode ray discharge tube experiment? It is nothing. So you can see it here. This is the cathode ray discharge tube experiment. Alright. So how did he discover electrons? I will explain how. So Michael Faraday in the 19th century conducted some experiments and found that when high voltage is applied to a cathode ray tube at low pressure with a gas in it, he found that some amount of matter gets deposited at cathodes and anodes. Some amount of matter gets deposited. Amount of matter, it can be anything. It can be liquid, solid, or gas. Okay. So some amount of matter gets deposited at these electrodes. Electrodes are nothing, just cathode and anode. Alright. Cathode and anode. So Michael Faraday found that matter gets deposited at these electrodes, cathode and anode. And using these results from Michael Faraday, J.J. Thomson further conducted some more scientific experiments to discover the electron finally. So how did he discover? So what did he do? So what he did was that, so he took a gas in this cathode ray tube. Some gas, we don't know what it is. He took some gas. So after taking a gas in this tube, and he applied some high voltage. He applied high voltage to this cathode ray tube, and there is some gas in this cathode ray tube. And he also made the pressure very low. he also made the pressure very low. So please please listen to these points. So first, number one, high voltage. So he applied voltage, high voltage, very high voltage. Okay, very high voltage. And next, he made the pressure very low pressure. He made the pressure very low. So under these two conditions, he observed that some rays have started traveling from cathode to anode in this direction. This is cathode, and this is anode. So when the voltage is high and the pressure is low, he observed that there is some movement of particles. Some rays have started traveling from this cathode end towards anode end, in this direction, from cathode to anode, from negatively charged cathode to positively charged anode. When the pressure is very low, and the voltage is very high, and using this experiment, he found electrons. And let's see the results of this experiment. So results of cathode ray discharge tube. So what were the results from his experiment? From the experiment that J.J. Thomson did. So the first point is the rays moved towards anode from cathode. As we can see, rays moved from cathode to anode. From cathode towards anode. And the rays are not visible to the naked eye. So the rays were not visible to the naked eye. So how did he observe those rays? How he observed was that he placed a phosphorescent material. Such as zinc sulfide behind. So he placed some zinc sulfide, phosphorescent material, here behind anode. This is anode, and here he placed some phosphorescent material such as zinc sulfide. So when the rays started traveling from cathode to anode, and when they passed this anode, and when they strike this plate, this zinc sulfide plate, they have formed some bright spots in this zinc sulfide. This is anode, this is cathode, and this is zinc sulfide screen. So when the rays started traveling from anode, and when they crossed this anode, and when they strike this zinc sulfide plate, they formed some bright spots. So earlier this was dark. So when the rays hit this zinc sulfide material, they form some bright spots. And this was how he observed these rays. These rays are not visible, but the presence of these rays can be detected by these bright spots. Whenever these rays hit this zinc sulfide material, there were bright spots. So this was how he observed the cathode rays. The cathode rays were not visible to the naked eye. They are not visible to the naked eye. But how did he observe these cathode rays? By using this zinc sulfide material behind anode. Okay. And third point, the rays travel in straight lines in the absence of electric or magnetic fields. So in the absence of electric or magnetic fields, this is the cathode and this is anode. So in the absence of electric fields, these rays travel straight lines. These rays travel straight lines without any deflection. What is deflection? Deflection is nothing but a bend. This is bend, this is straight, and this is deflection. Okay. And the fourth point, the rays get deflected in the presence of this is R, electric or magnetic fields. So these rays got deflected in the presence of magnetic fields. So if we place a electric field, this is an electric field, this is electric field, and this is magnetic field. So when electric field or magnetic field is present, these rays got deflected. So when electric or magnetic field is present, one second, let me rub this. So in the absence of electric or magnetic field, these rays travel straight lines. But in the presence of electric or magnetic field, they did not travel straight lines. They got deflected like this or this. They got deflected. So in the presence of electric field or magnetic field, they got deflected. The rays got deflected. And these rays behaved as similar as the negatively charged particles. So just like how electrons behave, and just like how we expected electrons to behave, these negatively charged behaved as similar as electrons. As electrons, and that is how these electrons were discovered. So these negatively charged particles are nothing but electrons. And the final point is that the rays don't depend either on the material of the electrode, or on the nature of gas used in the discharge tube. Okay. So these cathode rays do not depend on the material of electrodes. This is electrode. So these rays did not depend on and don't depend on the material of cathode or the material of anode. Excuse me. So these rays don't depend on cathode and anode. These rays do not depend on the material of cathode or anode. And these rays also don't depend on the nature of gas. You can take any gas. You can take nitrogen, you can take oxygen, you can take carbon, you can take any gas. But these rays don't depend on the nature of the gas. If you take nitrogen gas, these rays behave in the same manner. If you take carbon gas, these rays behave in the same manner. And if you take oxygen gas, these rays behave in the same manner. No matter what gas you took, these rays behave the same. No matter what gas you take, these rays behave the same. So, and that's the reason why these rays don't depend on nature of the gas. And also on material of electrodes, Okay. So this is it. So this is how electrons were discovered, and these are the properties of electrons. These are the properties of cathode rays. Okay. And in the next class, we will see the charge to mass ratio of electrons. E by M ratio. Okay, and let's quickly revise what we have learnt in this lecture. So we first saw why do we need to study this atomic structure. So why do we need to study this atomic structure is that this atomic structure is the basic and fundamental chapter to understand the concepts of chemistry. In chemistry, we deal with a lot of chemicals, lot of compounds, lot of molecules, etc., etc. And so in order to understand those concepts of compounds, molecules, or anything, we need to study this atomic structure. We need to study the concepts of atoms thoroughly, because every chemical is made up of atoms. Every compound is a combination of atoms. And that is why we need to study this chapter thoroughly. And this is a very interesting chapter, because everything in this universe is made up of these atoms. So if we can study these atoms thoroughly, we can understand how this world is made up of. This world is made up of atoms. And we also saw the concept of atoms, and we learned that the concept of atoms has been in existence since 400 BC. Since 400 BC. And we also learned that atoms are the fundamental building blocks of matter, and how the word atom was derived. And the atom was derived from the word atomio, meaning uncuttable or non-divisible. Non-divisible. First theory on atoms, and the first scientific theory on atoms was proposed by John Dalton in the year 1808. Okay, and we have learned the key points that his theory on atoms had made. So what did he say? So he stated that matter is made up of atoms, and atoms are undivisible. All atoms of given element are identical in mass and properties, and compounds are combinations of two or more different types of atoms. And also a chemical reaction is rearrangement of atoms. And what are the drawbacks of Dalton's model? So the major drawback is that atom is divisible. John Dalton said that atoms are not divisible, atoms are undivisible, but atoms are divisible. And he also failed to explain this phenomena, how the glass rod gets positively charged. And we have learned the discovery of electron, how Thomson used his cathode ray discharge tube experiment to discover the electron, and also the results of his cathode ray discharge tube. And these are also the properties of